Good morning and welcome to DDD 2020, our first online event. We're excited to see so many people join the session, and thank you for joining us from wherever you are in the world. We wish you all the best at this current difficult time. DDD 2020 is all about being an open and honest community and having the great community ethos.
Good morning and welcome to DDD 2020, our first online event.
Yeah, teasing problems already. There we go. So Stuart, if we can have the next slide, please. Yeah, so please be aware of everybody that's in the sessions. Please be friendly and patient with your questions and answers. We'll try and get to them as and when we can during the sessions. Please be considerate to everybody who are attending today. We may have some more speed bumps during the day, but we're doing our best, and we hope that you find the day very, very worthwhile and very, very enjoyable. And we are interested in your feedback at the end of the day so that we can build it into future events. Stuart, can I have the next slide, please? So for this event, we don't have traditional sponsors because we are not, we're not putting on sandwiches and food and things like that. So if you are able to and you would like to, we have a Just Giving page for the National Museum of Computing, and the details are available on the slide deck, but they're also available on the website for you to donate to if you wish to. It's a fantastic museum, which unfortunately due to lockdown restrictions is closed at the moment, but I've had the pleasure of being there and also being at Bletchley Park, which is joining to it. Going and having a look at Colossus and some of the bygone eras of computing from some of the early machines that I started with and all the way up to more modern things. So it is a fantastic museum and fantastic charity, and we need to do what we can to make sure that they survive the current problems. And in that auspice, we've had some fantastic support from our sponsors who have backed this event by donating to the Museum of Computing, and these are long-time supporters of DDD events. So again, if you take the opportunity to send a tweet or to say a thank or just to add some support, or maybe take a look at what they have, what they're about, and things like that. And finally, please tweet. Please make this day social. We've got the hashtag DDD2020. Our Twitter account is Developer Day. And as with every DDD event, please just enjoy the day. We appreciate you giving up some very, very precious time on a Saturday to support the speakers and to support the community. So this is about everything for you. So just please really enjoy the day. And with that, I'm going to hand over to Stuart.
Thank you very much, Andy. And I just want to give a big thank you to all the organisers and everyone involved in making today possible. I haven't been to a DDD event in over a year now, so it's much needed. So thank you very much. You can ask questions, and we'll collate them towards the end of the talk. So a quick intro. Hi everyone, my name is Stuart Lang. I'm a principal engineer at Justy and a Microsoft MVP, and I blog at stu.dev. And that's where you can find all my other bits and bobs. And if you want to hop over to my Twitter, my DMs are open if you want to chat to me about anything. And I'll be tweeting the slide deck out later using the DDD20 hashtag, which I encourage you all to use as well and get a bit of buzz going. I've got quite an ambitious agenda, and when I first put this agenda together, I was going to try to hit as many sort of things as I could, and I've realized that I've had to cut down a bit, so I hope I've got the balance right. So I'm going to move quite quick, and hopefully we can get into some code. So let's start off with what .NET 5 is. Before .NET 5 we had .NET Core 3.1, and we had a .NET Core 3, .NET Core 3.1, and we're fully expecting a .NET Core 4, but that would have been a bit confusing because we have .NET Framework 4. And so this invites even more confusion to an area that's already a bit confusing. So Microsoft decided to take the decision to sort of leapfrog 4 and sidestep that issue, but also take the opportunity to rebrand as .NET, because this is really the future of .NET, .NET Framework's now a thing of the past. It's kind of in maintenance only mode, if you will. And so .NET Core is no longer sort of this core new thing. It's the main .NET, and this kind of fits in with their new vision, which is like one .NET. And we also have Xamarin and Mono in the mix. So Microsoft acquired Xamarin a few years back, and they really wanted to bring this toolchain into the .NET SDK and have it be just a one-stop shop for everything .NET. And due to COVID and other reasons, Microsoft haven't quite got that bit landed in .NET 5, and they've slipped the timeline. So actually, that will come in .NET 6. So .NET 5 is more of the sort of promise of this one .NET and one toolchain. But it really sort of, for me, signifies that this .NET 5 is ready, and it's the successor to not just .NET Core, but .NET Framework. It's now ready for you to adopt. And Microsoft did all that work back along in .NET Core 3 with WPF and WinForms, adding those and adding in all the framework APIs. They added like an absolute ton of them back in the .NET Core 3 timeframe. So really, they've done all the legwork, and now it's kind of ready. And so it's really quite an exciting time. There's this excellent chart put together by a company called, I'm going to butcher this, but it's I don't know if it's Inedo or Inedo, but they're the company that make ProGet, and this is a really interesting chart around the release plan and support plan for .NET going forward. So you'll see that we are here at the moment. We're almost out of 2020. We're struggling our way out of it, and we've just got .NET 5, and what Microsoft are doing is they've committed to this cadence of every November we'll get a new .NET, we'll get a new major version. So next November will be .NET 6, then we'll get .NET 7 every single year, and every other year is going to be what they call a long-term support release. And so you can kind of see that here with the green bars. So that's a long-term support release. And so the regular releases are 18 months in length in terms of support, and those long-term support releases are 3 years. And I saw a comment on Twitter that kind of said, "Oh, I'm not going to touch .NET 5 because it doesn't have long-term support release," and they kind of said it in the tone that suggested you'd be a bit of a cowboy to migrate. And I think that's completely wrong. That's kind of a bad take. Microsoft are actually recommending and encouraging users to upgrade to .NET 5 and actually upgrade it every release. The long-term support releases are really about giving you that extra breathing room. So to clarify, although the most obvious thing on this graph is the length of these bars, and obviously if you choose to adopt the long-term support, you've got a longer bar, it's 3 years, right? But that's not the important thing I think we should focus on. The more interesting, I think, is around the overlap here. So the point at which November next year, you've got an upgrade path to a supported version, and the point at which your current version stops being supported. And so in this case, this will be 4 months from November to the end of February. So you've got 4 months there to upgrade and release that new version. And for many teams that are agile and have CI/CD, that's not much of an issue. But you can imagine some organizations and some teams, that's a bit tricky, and they want a bit more breathing room. And so if you were to only adopt the LTS support releases, the even numbers, you're going to get a year-long window here to be able to plan that migration. And for me personally, I found the migration from .NET Core 3.1 to .NET 5 was just changing the TFM for me, but obviously with a larger project, there could be more changes. But generally speaking, the upgrades are easier as it's matured. Another thing on this graph that on this chart that you can't really ignore, it's hard not to see, is the .NET Framework support. So here we have .NET Framework 4.8, and you can see it's going to be supported seemingly forever, and that's because it ships with Windows 10, and Microsoft are going to support Windows 10 until the sun burns out, and so that means .NET Framework is going to be around pretty much forever. But know that that's only in sort of a support mode. So they'll do security patches, they'll do hotfixes, but they won't add any innovation there. They won't be adding, for example, new language features. So, for example, .NET Framework 4.8 is stuck on C# 7.3 and will never get to a newer version. And that's the story for the Microsoft support. But if you imagine we have the same diagram, but lit through the lens of the sort of the wider ecosystem in terms of commercial support and open source support for libraries, that would be a very different picture. In fact, many open source libraries have already dropped support for full framework, and many are planning to. So here's a quote from Mark Gravel. Mark Gravel works at Stack Overflow, and his original tweet in here references this chart and says, I'm going to paraphrase, but you know, don't get a false sense of security. If you want support for full framework, you're going to need to pay for it, basically, because you know OSS, it's going away. And he then clarifies later on in this retweet that for them, for their libraries, they'll be stopping support for .NET Framework when .NET 6 arrives, which is November next year. And for example, you know, they support libraries like Stack Exchange Redis, Dapper, those libraries I use. And so, yeah, .NET Framework support from the wider ecosystem is very much going away. So if you have, let's say, a microservice or something that you have in sort of maintenance only mode, it really does need to be a maintenance only mode to stay on full framework. As these things start to, as you need to connect to new things in your environment, you may need new libraries, and who's going to be building those libraries? So this very much in my mind sort of signifies the end of .NET Framework. And .NET 5 and C# 9, those were announced last month at something called .NET Conf. I'll share a link in a second to that, but there's some really excellent videos in that, and one of them is this one here, which is around porting to .NET 5 from those legacy .NET frameworks. And there's a really great video here on something called Try.net, which is a tool that Microsoft have built to help you automatically migrate, and will do some of the groundwork. But this video in general just goes through the steps, how you'd analyze your plan to migrate off. So if you haven't done it already, now's the time to start looking. And I mentioned there .NET Conf. .NET Conf, you can get to the videos on YouTube. There's a playlist of 81 videos. There's a ton of content, and it's all amazing. There's videos on Blazor and all of the new stuff I'm talking about today. You can find much more detail by looking at the videos here. And then let's talk about .NET 5 features. And I haven't included all of them. I just wanted to, in the name of time, just kind of touch on the ones that are my personal favorite. So we have C# 9, and of course I'm going to get into more detail on that. And just a reminder that you have to be on .NET 5 to use C# 9. So there's no other languages that officially support C# 9. You can technically switch it on, and you can, you know, increase the langver to 9 on an older project, for example, .NET Core 3.1. But technically that's not supported, so you might have to jump through some hoops to make it work, and you probably don't want to do that. So if you do want to take advantage of those, the new language feature, you do need to be on .NET 5. Something I didn't mention earlier, I think I want to come back to, is .NET Standard and how .NET 5 relates to .NET Standard. That's been the way in the past we've rationalized all these different frameworks, and .NET Standard represents that common subset of APIs we can target to be able to run on all those frameworks. And .NET Standard is still applicable when we're talking about being able to target those existing frameworks. But going forward, we won't have another version of .NET Standard. .NET Standard 2.1 is the last version. From now on, .NET 5 is that common runtime. If we target .NET 5, and you'll be targeting that for not just your entry point projects, but your libraries as well, they'll be targeting .NET 5 and upwards. And that's how we'll be sharing code in the future. Probably my favorite feature following from that is in .NET 5 is performance. So this I've linked here to a blog post by Stephen Tube, who always writes a blog post about .NET performance every release of .NET. And in this link I share here, it took me between 2 and 3 hours to actually get through it all, because there was just so much content. So they've done so many performance improvements. And like I said before, my upgrade from .NET Core 3.1 was just changing the target framework. And so pretty much for free, you get all these amazing performance improvements. And they've improved performance right down from the tooling on your machine, so things like incremental builds are faster, all the way to JIT optimizations, runtime improvements, and API improvements. So one of my favorite examples he gives in this post is They had customers that had very common regular expressions that were quite simple, and they were able to just optimize those common cases, and they had an order of magnitude performance increase. And so just by upgrading, you get that for free, which is pretty cool. Another great feature is single file apps. This is something that they kind of had back in .NET Core 3, but it wasn't as well engineered as it is in this version. So you're now able to, in your project file, say that you want a single file deployed, and when you publish your solution, what you'll get is one binary file that you can run that contains the runtime and contains all the DLLs and contains everything. In the .NET Core 3 solution, it kind of self-extracted to a temporary location and kind of ran over there. So this is a better engineered solution for that. And a similar feature that goes hand in hand with this is something called app trimming. In that case where you've bundled your app and you want to share it with somebody, you probably want to get it as small as possible. And app trimming is a feature that's come from Mono, where it will do sort of tree shaking of the IL that you're not using, and methods and properties and all the rest of it that you're not using. It tries to do that with some smart heuristics, and it does a pretty good job. But if you're using reflection, there's things that may not know about. So if you do switch this on, and you'll know this if you've worked with Xamarin, you might need to get involved and kind of give hints to say, hey, preserve this and don't cut this, and maybe switch off certain third-party assemblies from being involved in that trimming process. But it's a really nice feature and kind of rounds out that whole story. System text JSON. This is the new .NET serializer that shipped in the .NET 3 timeframe. And in this version, they've improved it because there were some features that weren't quite there and that they've added in .NET 5, and that includes things like cyclic references, support for immutable types, which is obviously very relevant with C# records that I'll talk about later, but it's also good for F# records as well. And then there's F# 5, so I have to include this because I'm a bit of an F# fanboy, and I won't go into too much detail on this release, but I think this release is kind of not funny, but kind of interesting in the way that this is the release that F# borrows a lot of features from C#, and historically it's been the other way around. So in this version, F# finally gets string interpolation, which is just obviously, as C# developers, we know is amazing. It also gets support for it will at some point get support for native interop with tasks. That's not quite delivered yet, but that's coming, and that's something that at the moment you need libraries to be able to interop with tasks, and so yeah. And there's tons of other little features that I just don't have time to go into. I think there's it's ARM64 support. I saw a tweet yesterday that someone's got .NET 6 running on the Apple Silicon M1 chip, which is insane. So yeah, there's some amazing stuff happening in this space. Lots of good reasons to upgrade. But for me, the big one is C#9. That's the one that's pulling me towards .NET 5. So let's take a look at some of the C# features that are new. And we're going to look at some code snippets, and I'm going to be doing some code demos. And the first one I want to kind of show is top-level programs. So this may not be something that you particularly will get much day-to-day benefit from, or not something that you feel like you need. But the big benefit of top-level programs is for beginners to .NET. So if we jump over to some code, and I hope you can all read this. When we create a console app, or just get started with C#, this is almost always what we see. We see like namespace, code braces, indentation, class, program, public, static, void, main, string, array, args, and some of us as seasoned .NET devs, we don't even see this now. That's just noise that we subtract, and our brain goes straight to this line here. And if you're a beginner to C#, you're asked to ignore all that. We'll get to that later. We're going to write some simple code here where we, experiment with variables and stuff. And as a beginner to a language, that's really hard to just ignore. You want to know what all this stuff is, and so having top-level functions or top-level programs means you can just omit all this and just start writing code. And so we can do console. I can't spell today. .WriteLine. Hello. And if we run that, most unexcitingly, we get hello. And so even if this isn't something you feel like you'll use day to day, the benefit for newcomers is huge. And that on-ramp, having a smoother on-ramp for new developers, I think is such a win for the ecosystem. So that's awesome. If we look at some of the details around how this is implemented, you can say we can have a function here, return hello, and we can invoke that here. And so if you include functions, those are actually local functions. So it's as if you had it in the main block. And so we can actually move that welcome method above that code, below the code. We can continue to write code below it. As soon as you introduce a class declaration, however, that signifies the end of the statement, the top level statement. So if we try to write some code here, for example, console.WriteLine, it's going to tell us off and say we can't do that. But you can have one file with lots of types beneath it and then your code at the top if you're just hacking around on something or doing a code demo like this. Something else is that we haven't returned anything. We haven't said like return 0 because it's implicit. We can explicitly do it if we want to, though, as I'm doing here. Something else that's implicit is I can await task.delay. So we can await tasks and the compiler will look at that and say, oh, you're waiting, in which case this top level program, this statement must be async. I'll make the entry point async. And finally, something that we'll want to do is get access to the arguments. And by convention, we use the parameter name args because it's the default that comes with the template. And they've now decided to make that a predefined variable. So you can see there we can. Oh, I can't type today. We can DOS into that and do what. Oh, excuse me. I've lost my code window. Let me just get that. Let me just get that back. Enter presentation mode. Phew. So yeah, and I said this is something possibly for the benefits for newcomers, but I personally am going to be using this because I don't want all that nested noise. I want to bootstrap my app and get going. So I think it's a really nice quality of life improvement. And now we have patterns. Someone asked in the comments the first question, what's my favorite feature of C#, C#9? And I think the one that will have most impact day to day will be patterns. And so let me explain why. So patterns were introduced in C#7. And when they were first introduced, I don't mean to be mean, but they were a bit underwhelming. And that's because the scope of what they implemented was quite narrow. And then in C#8, they added a ton of features to it. And in C#9, they've added some more. And it's now really well-rounded. It's now a really nice set of features. So for example, if I have a, let's say I had a string that I cast to an object here. This is just demo code. I'm not very creative with this stuff. Say here I have an object, and just a reminder of pattern matching, I can say O, and I can use the is operator and then use a pattern to match on that thing. So for example, I can use a type pattern and say string, and that expression returns true or false, depending on whether it's a string or not. And ignore the squigglies. This is Rider trying to tell me you're doing something silly. Clearly, this is not going to be. Clearly, it's always going to be true. But pattern matching also doesn't just let you do checks and sort of check that something matches a constraint. It can also unpack variables in the same expression. So for example, I can say string s, and now in the case where it does match, I have s bound to the, with that narrow type of string declared. And so you'll commonly see this rather written than something like this. You'll see patterns used in if conditions, because then in our block we've now got any variables that were extracted as part of the pattern match will now be in scope. So that's one way of using patterns. There's a few other contexts you can use them in, but one of my favorite has to be switch expressions, which is something that came in, I want to say C#8, not C#9, but it's part of that overall feature set that I want to show. So let's say I had an integer 5. I need to come up with more creative examples, but let's say I want to print something based on this integer. So I'm going to switch on it with a switch expression. So it's still that switch keyword that you had in the olden days with switch statements, but it's an expression. And now we need to provide patterns for each arm of this for all of our cases. So one of the patterns we can use is a literal pattern. We can say if it's 4, it's 4. And one of the new patterns we have in C#9 is a relational pattern. So we can just say greater than. So I can say greater than 4. Greater than 4. And if I compile this, hopefully you'll see at the bottom here, I'm getting a compiler warning. Oh, it says I haven't handled all the possible values of the input type. And so the compiler can see in this case that I've not been exhaustive in my pattern matching. So this is really good. It helps us catch bugs. So I can say, or in a default case, you know, throw an exception or print some fallback. But equally, I could say that's greater than 4. I've handled 4. If I handle less than 4, less than 4. If I build it now, the compiler sees that I've satisfied, you know, I've exhaustively matched all the possible inputs. So that's really nice. Another feature that they've added in C#9 that makes this really quite nice is what's called logical combinators. Logical combinators, which are these keywords, or, and not. So this makes these expressions a bit more powerful. So in this example here, where I had greater than 4, what if I want to say greater than 4 and less than 10? So basically between 4 and 10. Now I can say, let's do that. I can say and less than 10. And so just by them adding this and combinator, I now have a way of saying between. So that's really quite nice. The or combinator is really handy. So let's say, let's go back to our string. I could match is match. I could say is hello. But with the or combinator, I can say or something. Or so I can have a list of things that this thing matches. And previously, we'd have to use, like, if we use a regular Boolean or operator, we'd have to say like, oh, is this, oh, is that, oh, like we'd have to keep repeating the source thing we're matching on. And so we can just do things a bit more concisely with this or combinator as well. And then finally, in these combinators, the one that's going to have most impact on my day-to-day code is the not operator. And that's because, let me make this an object again. Oh, it doesn't have to be, but I want it to be. So many times in our code, we see this. We see if something is not equal to null, do something. But the way I read this is if O is null, that's how I think about it. And when you say equals null, what you're really saying is, does the equality operator consider these two things, null and this object, to be equal? But what we're almost always trying to say, or we're actually trying to say, is this thing null? That's what I really care about. Is it null? Because I'm about to dereference it and I want it to not blow up. I don't want to rely on the implementation of that equals thing working, which it almost always does, but I don't want to rely on that. And so I can say is null, and this is a bit of pattern we can use for a while with pattern matching. But the problem comes when I want to say is not null. And so I could say not O is null. That doesn't flow very well, and there's a lot of punctuation there. It's It's a bit gnarly. What we've also been able to do is say is object. So for a reference type, that's a way of saying is not null, basically. But it's I don't know, it doesn't read very well, in my opinion. It's not very nice. So what I started doing was this this property pattern. So let me take this object off for a second. So it's a string. There's a thing called a property pattern, and what you can do is you can say things like you can constrain lengths with their own patterns. I can say length is 5. But for the property to not throw a null reference exception, this pattern needs to kind of handle the null case. So just by having curly braces, that's what the pattern does by default. It checks for null and then checks the inner property constraints. So just by having an empty open close curly brace, you're basically saying is not null. And so that's actually how recently I've been writing is not null. And I checked that, I put that into a pull request, and somebody commented saying, what the heck is this? And I was like, okay, yeah, we're not ready for that. That's probably not right. But thankfully, just with as simple as it sounds, this null combinator, sorry, this not combinator means that we can write is not null. And as simple as that sounds, that's exactly what I want to write. That's how I think about it. That's how I say it. That's how you think about it. It reads as English, and all over my code, I have not null, not equal to null. And this is going to be the thing that I've used the most, even though it's the tiniest thing. It's going to be the thing that impacts the most on how I write code. That's patterns. I've only showed you some patterns. There's lots more. There's tuple patterns or positional patterns, because you can also deconstruct something, and there you can constrain one of the values in the tuple or the deconstruct, and you can also unpack a variable of the other one. So that's really nice. This is a way of just keeping code nice and concise. I asked on Twitter for people to give me some examples of some code they like, where they've applied patterns and it's made their code better. I'm going to start with this is an example I've seen a recent code base, and there's nothing wrong with this code, but notice we have these if blocks, and each of those blocks return, and then finally out of all of those we then return again. And so you have to kind of check that all the branches return. If they do, what if one of them doesn't? And it's hard to at a glance figure out what's really happening here, even though this is such simple code. So this code here is like trying to do a crude implementation of, in SQL you have a like syntax where you have a percentage at the front or the end or both, and kind of have a wildcard matching thing. In this example, this is the same code, just tied it up with, and these are only C#8 features, there's no C#9 here. I've used index and range. Let me get my pointer out. I can say this is a C#8 feature. I can say last but one character, the end character. And then I can put that in a tuple and match the tuple with these positional constraints. And again, I'm using slices. And so this has become really clear that I'm mapping, I'm matching the source with pattern, and I'm doing it based on the first and last. And it's really clear what the flow of data and what's happening. So it's just more concise, it's just more expressive, and there's less places for bugs to hide. I really like this code. Here's an example from the Microsoft docs, and this one's just showing property patterns. So in this example, it just gets a little bit more concise, and we're using the OR combinator, and we're using property patterns. This is just aesthetics, but it's just one of those things. It's just nice. Here's some I got from Twitter. This is a really nice one. Here it isn't really obvious. You kind of have to parse it mentally. Here we're just saying is enumerable and not string. It reads much easier. Another one from Joseph here is with the property match and the not expression. Again, it just structurally reads easier than the previous version, where you had to kind of make sense of it. And another one, again, showing where you would use the old traditional OR operator versus the OR combinator, you can now kind of have a list of values you're checking something against very easily, and that's something we do commonly, and I see that being something I'm going to use a lot of. So that's patterns, and of course the headline feature of C#9 is records. So I want to get into records, and just before we get into it, I just want to explain the importance of them. I think that the main difference between building something that works and kind of engineering something is modeling. As developers, we are domain modeling. We're modeling systems, we're modeling concepts in code. And when you think about maintainability and kind of building a successful system from a code perspective, it's all about being able to express that in a good way. And the language needs to allow us to domain model effectively. And C#'s evolved over the years to help us with that. So classes used to be very verbose. They're now much more concise. But we've been missing something from the domain modeling story, which is this idea of in domain-driven design, you have the idea of value objects, which have structural equality rather than referential equality. And kind of a consequence of that is that they're usually immutable, and we'll see why in a minute. And immutability is something that lends well to functional programming. So records is something we've really wanted for a long time, and I'm really glad they've taken the time to get it right, and we're going to see that it's a really nice feature. So for this random curly braces I'm putting in, I'm using an EAP overrider, and I want to make sure that the code I'm writing doesn't break. I don't want to explain it, but like every time I write some code without those curly braces, it breaks the parsing and it doesn't see the record, and then sorry about the braces. So to define a record, we can now use the record keyword just as we would the class keyword. It's the same sort of thing. We can say the type name, and in this version I'm showing you a positional record where we're creating a default constructor, and it's creating a bunch of stuff for us by default. And you can put a body here, but I'm defaulting, well, I'm just going to omit it and put a semicolon. And so that's a nice new feature. And if I say new person, do it up here, I'm going to have Stuart. Live coding. And then we're going to have person 2. And it's going to be the same, right? And in class land, if I did console.writeLine and I said, does P1 equal P2? The answer would be no, but I think you won't be surprised when I say records have structural equality by default. And so this equals true. And if I changed the property, they wouldn't be equal, of course. But if you're wondering how that works, let's have a look at sharplab.io. So this is a fantastic tool where you can put in your C# on the left, and it will generate you code on the right. It will show you the decompiled code on the right. So I'll explain this this bit of extra code here. I need to put this in, otherwise it won't work. But we're just focusing on the person record for the moment. If we look at what it's created for us, it's created a class that implements equatable of person. And so you're going to see a lot of boilerplate that it's created for us that's nice. It's created the auto properties for us with the backing fields. It's created a toString that's really nice. It's pretty printed with a person, curly braces, comma separated, first name equals first name, last name equals last name. All the equality operators, the equality method, the get hash code that would correspond to those equality methods. And then it's given us a deconstructor that matches the positional constructor, which is nice. Let me get back to the code. What this builds for us implicitly is these properties here. So string. Oh, yeah, look how prepared I was. Cool. So it automatically generates these properties under the hood for us, and it generates them with a new language feature called init setters. And so we can actually add these to classes. They're not actually tied to records. And this init keyword lets us, if I take the constructor out here, so we can have records that aren't positional and just have these properties. And if I come up here, you need to use the object initializer syntax. So first name. Oh my God, I've broken everything. Person record. I shouldn't be using AAP. This is my fault. First name equals. Goodness. Typing under pressure. Nothing's working. Oh, curly brace. There we go. Oh, that was more painful than it should have been. So we can use this these init properties, and what they will do is they will let us initialize these properties and set them during the initializer phase. But as soon as that last semicolon is hit, it's sort of frozen and it's kind of read only. So if I come in here and I say p1 dot first name equals Stu, it won't let us. And so when we come back here, notice this this extra class we had to include that is actually part of .NET 5. If you search the code on the right, you actually won't see it anywhere in that decompiled code. If I look at the IL though, what it's used for, and it may take me a while to find it, get a first name. Here we go. Here we see set first name in the IL, and it's decorated with this modrec IL thing. And that is a way of letting us decorate this thing and decorating it with a modifier saying it's external init, which means it's a setter that is allowed to be set, but only in the external init phase. So when the .NET 5 compiler sees this, or a compiler that understands C#9 and above, it knows what that does, and it enforces the fact that you can't set it after the initializer. So here, when I'm trying to set surname, oh sorry, I'm trying to rename my forename, first name, and it's not worked. So how do we copy these things? Well, we can't modify them, so we have to copy them with changes. So there's a new keyword that is with, and it lets us use this property, this initializer syntax, where I can change the name. So now I've got a P2 that is a copy of P1 with that property change. Something else you can do here with the record is you can displace any of the auto-generated code. So by putting these properties in here that match the names of the generated ones, I basically displace the ones that would have got generated for me and overridden them. So I can define my own toString method, equals method, all the rest of it, and then the auto-gen version won't be produced. You can change these things from an init to set, so you can make some of them mutable. However, that's not necessarily a good idea, because if you're using this as a key to a dictionary, it's not going to work. Well, if you use this as a key to a dictionary, remember the get hash code was also generated for us. So if we change that property and change the value of it, we've changed the hash code, and now that object is no longer a good key for that dictionary. We won't be able to get the value back out. And so you have to think very carefully about mixing this sort of record semantics with mutability. Be very careful of that, and try to keep things immutable. So that's records. I think I'm running short on time, so I'm going to have to just blast through this last one and get onto the questions. Let me present again. Source generators. This is one of those features you probably won't be using day to day. You're certainly going to be not going to be writing one of these day to day, but they're really cool, and they open up this interesting new space of what's possible with C#. And what's interesting about source generators is they're not really a language feature. They don't actually impact on the language specification at all. They're really a language experience feature, in the same way that rosin analyzers are a language experience feature. They kind of light up your development experience and suggest you fixes, but they're not part of the language, and that's very true of source generators. They open up a whole bunch of possibilities for library authors around where you might previously have used reflection and IL emit. You can now generate source code. So let's have a look at how this works. So very simply speaking, you have your program code. That gets passed to a source generator. And we're going to look in a second a bit more detail about what that looks like. But a source generator could be something that's in a separate project or in a NuGet package somebody's built. It's a bit of code, a block of code that will get your program from Roslyn, and we'll look at what that looks like. And its job is to output some source code, and it literally outputs it as a string. And I say output, it doesn't write it to disk, it adds it to the current compilation in memory. And that means that it's available to you back in your program code immediately, near immediately. You get like the IntelliSense has already got that generator code in there. And it's all pretty cool. Now, bear in mind, this doesn't replace things like FODI and IL weavers and all those sorts of magical things that like mutate and modify code behavior. This can only add code. So you have to kind of limit your vision for what you can build in terms of, can I do this by producing code rather than modifying anything I already have? There's a fantastic tool for demoing this. I'm going to show you very quickly by David Wenger, I want to say. I hope I haven't butchered that. That basically, this is like a visualizer where you can have your program code, the source generator code. It visualizes that generated output, even though it doesn't hit the disk when you actually have a source generator. And then it runs it on the bottom left. And this is a really nice tool for being able to play with these things and kind of figure out how they work. And we're going to look at this in a second. Before we do, we kind of need to understand how Roslyn works before using source generators. Roslyn takes your source code. It then parses it into a syntax tree, which understands things like if blocks and all the rest of it. But what it doesn't know at that point, it doesn't know, for example, if you're inheriting from a type, it doesn't know that the type you're inheriting from, it doesn't know where that lives, it doesn't know what fields that has, it doesn't know whether those are private or protected, and if you have access to them. There's a whole bunch of stuff that the syntax tree doesn't know about. And to know about all that stuff, you need to resolve assembly references. You need to get your NuGet packages and your project dependencies. And this is all done in a build. So we need to do a design time build to be able to get this information. And that's how IntelliSense works. For IntelliSense to be able to tell you what you have access to, it does a design time build, it gets the semantic model, and then is able to give you information based off that. And then when you do a full compilation, the final step is taking that rich semantic model and actually emitting IL into assemblies. But for language services and when we're building, when we're writing code at design time, we don't do that last step. And so what we need for source generators is we need to deal with that semantic model and those syntax trees to be able to, that's what we have access to be able to do stuff. Oh, I'm running short of time. Okay, demo time. So I'm going to use source generator, sourcegen.dev. This is a fantastic little site to demo this stuff. If we start with the source generator itself, it implements iSource generator. We have an execute method and a initialize method. And the initializer is where you can sort of subscribe to stuff and do some setup. And the generator is where the execute is where you're actually going to add some code in. So in the output of this hello world thing is it's going to add some source and it's going to literally add a string. And this is the string it adds. So this is visualized for us. This is then injected back into your code and is available for you immediately. So here we're dotting into it, into that code that was generated for us. And here's the output. I want to show you an example I have here. I thought what would make a good demo. And I thought what would be really cool is in F# you've got JSON type providers where you can have a constant compile time constant JSON string and say, hey, give me the types for this thing. And so that's what I've built here. I've got a JSON field where I've put in a string. I'll take this bit out. So I've got some JSON and my type provider takes a class name. Well, it has a, sorry. I've defined a type where I take a class name and I'm going to generate a class based off of that. And here I'm using that class and it's been generated for me by the source generator. And so just to show you the magic of this thing, if I dot into John here, I can see first name, last name. But if I add an age property to my JSON, age appears and is typed as int. And so I've actually stolen a lot of code to make this work. And this is like a fudge of lots of things I put together. But I thought it'd be interesting to kind of show you how a source generator looks like. So here's my source generator. I implement iSource generator. I have a sort of I define the attribute so that even if nothing happens in the generator, it generates the attribute which you can then start using and decorating your code with. In my initialize, I register for syntax notifications so I can get a syntax receiver. When my execute method runs, I have a context. I can add the source of that attribute to my context. And I can then start looking through the syntax tree. I can get the semantic model. I can look at all the types in the code. And it's a lot of fun to build this. And then ultimately, some code I borrowed from somebody else, I can generate a class for that JSON, and then I can add it to the source. And I literally toString it. And so if I come back here, Rider has a really nice feature where you can actually F12 in, and it spits the C# file out to disk temporarily. So this is what it's generated for me, even though it's not on disk, it's actually in memory. Things to point out, I did this very naively. I did it by building it here in this solution, which is really silly because the developing experience is not great. You really want to hook this up to unit test and drive it through that, and then just do your last bit of testing in the IDE itself. Something else to point out is that building these is actually not a great story at the moment. They kind of got they've got everything in place in terms of the design of this, but the actual building story around it is not fantastic. So an example of this is I can reference packages, and if I have a dependency that I need somebody who consumes me to have, I can have a public NuGet package dependency, and that works like any other package reference. But here I wanted to use Newtonsoft JSON, but I didn't want anybody who consumes me to have to want it. This was for me to be able to generate that code. And so I can say it's a private asset, but in terms of actually using that in the source generator itself, I have to then add all these little magic hooks, and then I actually have to go get the assembly manually. And this is kind of gnarly, right? So be prepared that if you are going to build one of these, it's going to be a bit hard work to kind of get there. But ultimately, this is pretty cool, and this opens up possibilities for library authors and there's potential to sort of have performance optimizations where you're not doing things at runtime anymore, you're doing things at design time. I think I'm gonna have to call it there for source generators because I want to get on to questions. Let me get back to my slides. There were other features that I didn't get into, things like targeted new and loads of other little nice features of C#9, but I want to get on to answering questions. So thanks for having me. Let's have a look at questions. I'll bring up the Q&A right now.
Okay, so we have heard that folks have had trouble submitting questions. I'm not sure what the issue is there. I'm checking in multiple browsers at the moment. I still see the option to submit sessions. So if anybody would like to, then as Stuart says, he's here to answer those questions for the next 6 minutes. There is a comment. There is a comment being made by one of the attendees around the operators reminding them of VB.NET, which is
yeah, and actually I have to say I don't know too much about the VB.NET syntax, but yeah, I'm sure inspiration's been brought from all different places, and which is good in my opinion. But yeah, I wouldn't be surprised if that actually came from somewhere else. Yeah, very cool. Recent slides. Yeah, no questions. Oh, I don't know how to use my 6 minutes. I'm tempted to go back into that source generator.
If anybody's having, while Stuart's dropping into that, if anybody's having problems asking questions in Teams, but wants to reach out to me directly at AP Westgarth on Twitter, then I can relay them directly in the session, and then we can handle it that way.
Yeah, if you can equally, if you can tweet me fast, I will read it and answer it. Whatever we can do in 5 minutes. I wasn't ready for no questions. I wonder what else I can show with type providers. Oh, sorry, source generators, I should say. I should say that the code for this isn't public. I don't intend to actually release this type provider, this source generator, I should say. because it was more of an experiment for me to kind of get to grips with how everything works. But I will put it on GitHub. I just won't be supporting it or pushing a package. I'm gonna create my own questions. You may say, is this really something you want to be using in production? It adds a lot of machinery to the whole build experience, and yeah, that's true. I don't think I would use this for production. This is more of like a productivity tool. That's the way I see this source generator being used. But I could see source generators in general being really like having lots of different use cases. One of them is productivity, one of them's performance and flexibility, not having to do reflection at runtime.
If you Q&A in the queue now. Peter's comment, sounds to me there is a limitation to the source generator that it's tied to what's available in the default assembly load context. Do you think this will be addressed?
Tied to what it's loaded in default assembly load context. Oh, I don't know that I understand the question fully, to be honest. You have access to the, if I scroll up here, you have access to this context. This context has the compilation and the syntax trees and the semantic model. You can add to that, but anything you add here won't then be subject to other source generators. I don't know how limited. I don't think it's that limited. Like you can load in stuff and do crazy stuff. I've been doing a lot of stuff recently around this space around metadata load context and working with the Roslyn APIs. There's a lot you can do with this. David Fowler has a project he's working on, like it's a little hack he has, if you look at his GitHub, called uController, or I think it's supposed to be microcontroller, and he's using some of this stuff. He's using source generators, and he's built a little shim to translate source generators, the Roslyn semantic model to a metadata load context, where you can basically get reflection APIs shimmed and translated to the semantic model APIs. So there's a ton of stuff around this. Other things to talk about are in source generators, you're literally building up string sources, and so there's no one library out there for helping you write C# code, but there's lots of competing libraries. There's no one winner yet, so try them and see what you like. I've got questions. Yep. Yes, I will make the code available. I'll make the slides available. Any demo I did today, that won't be made available, but the source generator, I'll put it public, even though I won't be building it. Source generators replace things like nswag for Swagger. Possibly. I don't know. It certainly can be. Whether or not those things change enough for it to be warranted within the language service, I don't know. Maybe. Anonymous asks, I hear there are breaking changes with string comparisons. Are there other breaking changes? Yes, there are. That's a very good shout. There was something around string comparisons. They changed the sort of underlying libraries they used, and that caused issues. There are other breaking changes. They've been documented. I've not run into anything too nasty, but yeah, you'll have to read the docs. I think that probably draws us to a close then.
I think so. Questions around feedback forms. Yeah, I think we're putting something together for the end of the event. We had thought we had another mechanism for each session, but I think we're going to put something towards the end of the event. So you'll probably see an announcement in one of the other sessions. And thank you for your support, and thank you, Stuart. A very interesting session.
Thank you for having me. It's been a blast. All right, take care, everyone. Enjoy the rest of your Saturday.